Hello, welcome to this first class, Public Policy Analytics. If you are watching this recording instead of having me do this live, it means that I have recently had or am currently having a baby, which is exciting and terrifying, and I appreciate your patience in that I can't be with you for this very first class this semester. I'm going to give some slides today. And I promise you will have lots of time, either via Piazza or the lab after this course, or via email, to ask any clarifying questions you have of the course. And I'm going to jump into it. Let me share my screen. So welcome. This is, I think, year 7 or 8 that I've taught this class. It has changed a lot since I first taught it. And this will be the first year where the class will be taught entirely in R, and I'll talk about that towards the end of my slides today. And I also need to mention the team that is going to be teaching with me this semester. The two lab professors, Michael Fitchman and Matt Harris. Thank you to the two of them, as well as Tyler, our TA. Between us all, we work hard to really pile a number of new skills into your brains over the course of the semester. And not new theoretical skills, although there will be some of that, but really applied skills that we hope that you will take and use to solve all sorts of interesting problems that you encounter with data. This course is called Public Policy Analytics. It is a data science class, which is a contemporary term, but it means data-driven decision-making. But it is specifically geared towards problems that we encounter in the public sector. Many of the things that you learn here, in fact, most of the students that come before you, they use these skills in the private sector, specifically all the many geospatial data science skills that you will learn. But in doing this work in the public sector, it is unique, all right? I'll talk a lot about that in these slides today. Here's what we're gonna do. I'm gonna give you some important context. I'm gonna tell you about why spatial thinking is such an important part of what we do. If you were here for a GIS class or a spatial analysis class, you will absolutely get that. I don't think it's a pure GIS class because I think that the problems we take on here are so very applied. It's not just about putting points on the map. It's not just about making pretty maps, although you will see data visualization is a really important part of what we do. Then I will go over the syllabus, and finally I will talk about the course text for this year, which is something I've been working on for a long time, but it will actually be a finished book in print, and it's accessible for free online. You don't have to pay for it. But all the code and everything that we're going to access for this course can be found in this text, so I will go over that as well. Now, normally I would say you should feel free to interrupt me and ask any questions if you don't like anything I say or it brings up some uncertainty. Obviously, you can't do that. I wouldn't try. It'd be a waste of your time, given that this is recording. But please write down any questions you have as they emerge and let me know what they are. Piazza, you will see, will be the best way to do this. I'll show you our Piazza site towards the end of these slides. So I want to start with a story from New York City that played out over the last couple years. New York City is probably ahead of any other American city in using analytics to make decisions. And not just like putting points on a map, not just using Excel and PDFs, but specifically using data to guide decision making. And they've been doing this enough across enough agencies that it was decided that they needed to know or understand how these agencies were using data to make decisions. So they established the first of its kind anywhere in the US, an algorithmic decision-making task force. And they got together a whole big, interesting group of professionals, a really interdisciplinary group, and from like sociology, computer science, ethics, the law, And they started going around to every agency, this was mandated by the city, and saying to these agencies, we would like to see your algorithms, please. A couple years later, about a year and a half later, they went in front of city council and complained that not a single agency had been transparent about the algorithms that they were using. 2.5 or so years after the task force was brought together, they issued their final report, where just a handful of the pages of the report were actually devoted to findings. Most of it was like fluff, like bios and things of this nature. And then it's worth reading, in the winter of that year, 2020, the AI Now Institute in New York City released a shadow report and really pointed out the failure of this idea. Why was New York City unable, why would they mandate the need for more governance around their algorithms, but were unable to actually do so? Why is it that they were stonewalled by every agency when they asked for their algorithms? And this is the question I just asked you. Why was, we call governance, by the way, the need to put this technology into terms and processes that we are familiar with in government. We call that governance. And so why was this effort such a failure? And you can think of a number of reasons why this was a failure, but what I would like to impress on you and have you put in your pocket for the course of this class is that algorithmic decision-making, using data to make decisions, is just a new take on the way that governments traditionally design programs. And I know that that's a very loaded sort of sentiment or statement that we'll get into a lot. But any program in government, there's some mechanism for deciding who gets access to a resource or how. Algorithmic decision-making is not much different than that. It is different, but it is the same role. Who, where, and why should they get some sort of resource? And when you start thinking about algorithmic decision-making, not as this strange, futuristic concept of AI and all this nonsense, if you think about it as a means for deploying resources, it helps to ground the kind of work that we do. And once we start with that, then we can build all the technical stuff on top of that. And then the way that I like to start this conversation, the way I like to think about this work is to start by understanding decisions and decision-making. That is at the core of what we do, is to use data to make decisions. Now in government, there are two kinds of decisions. These are the two that I like to think about. The first is budgetary decisions. And these are, I think, what most traditional academics are interested in. This is like, we identify a problem, we pass a bill for $50 million, and then what happens? That money is then sent to a department, to an agency that needs to figure out how to allocate that money in $50, $500, $5,000 chunks. And that kind of operational decision-making, sometimes we don't consider it. We just assume, it's such a win that we've appropriated all of this money for this really important or progressive idea. But the devil's in the details. If that money is not doled out as an effective program, it may be a waste entirely, even if the policy behind that program had really terrific intentions. And so the focus of this class is very much on this idea of operational decision-making, day-to-day decision-making. And I have sort of identified 4 different ways that decisions get made in government. This is really just sort of my experiences. So the first and least common way is ad hoc decision-making. Why do we do it this way? I don't know. And it's really not particularly common, and I think it's probably most common when decisions are made by individuals who are free to act autonomously, particularly in the absence of some top-down decision-making machine. So that would be like inspectors, for instance, who are given some loose guidelines for what to inspect and when, but ultimately go about their day-to-day inspecting whatever it is, factories or properties, etc., where there's not a rigid set of decision-making criteria. The next form of decision-making is political decision-making. Why do we do it this way? because I can't afford to upset the elected official who sets my budget every year. This is super common, and probably most common in the context of growth coalitions. For the the planners among us who are familiar with this idea of growth coalitions, it is those that tend to have political capital tend to be the ones who invest in cities, who invest in real estate. They tend to have the ear of representatives. For whatever reason, if a group is able to capture a disproportionate amount of political capital, then there's a high likelihood that government decisions will go in their favor. So why do we make a decision in favor of those people? It may just be political. There's no way to get around politics, even if you believe that a data-driven or evidence-based approach is the way forward. The third type of decision-making is institutional decision-making. Why do we do it this way? Well, because we've always done it that way. And this is really common. And as government has kind of progressed from Tammany Hall political machine governance to a system of checks and balances, a set of incentives emerged that were really designed to maximize efficiency, promote some kind of rational decision-making, and ultimately prevent corruption. And the bureaucracy that resulted from this is very top-down. There's a clear division of labor. It's based very much on practical expertise, like lots of rules, effectively. And while this bureaucracy may be helpful, it may disincentivize some innovation. And why do we do it this way? Well, the alternative might not fit inside those bureaucratic constraints. Even something simple is you go to work in a government agency and you want to put R, a free open source statistical software, on your computer. And the IT person says, I don't think I can do that. I don't really have control over that software. I don't know what it is. It's not approved, and we can't do that. You can see right off the bat how that would prevent some data-driven innovation from taking hold. And then the fourth and probably most important decision-making approach in government is evidence-based decision-making. Why do we do it this way? Because the data suggests it's the best approach. And that is obviously the gold standard. It's very difficult to do. And so the second big theme of this course is that proactive decision-making is preferable over reactive decision-making. And data and evidence is a way of getting us there. So reactive decision-making is, wow, COVID seems to be killing a lot of people, but hopefully it'll get better, and we'll just keep doing what we're doing, or we'll slowly try to make some improvements. Proactive decision-making is, no, I can see this hotspot emerging right here. At this time, I need to pivot my plan to get resources there right now. Proactive decision-making is the algorithm that can detect people who are at risk of homelessness, can detect buildings at risk of falling down on people's heads. This level of proactive decision-making is enabled by the kinds of data science skills that we're going to learn in this course. So I know what you're thinking. You're like, dude, why is this guy talking about all this political science and sociology, all this stuff about bureaucracy? I thought I was here for a data science class. Well, yes, we're going to learn a tremendous amount of technical skills. But my goal is to prevent you from turning out like this asshole who, sorry if that term offends you, but I kind of feel a certain way about this guy who said this thing that, a strong way to innovate is to move fast and break things. And that's what he did. And he made a tremendous amount of money. This is Mark Zuckerberg from Facebook, if you don't know. He did move fast and break things. They made a lot of money, but the things that he broke are not to be taken lightly. And the first reason I think it's important that we have this context in hand when we do this work is to know that breaking things, when you're interested in equity, when you're interested in public health, when you're interested in economic empowerment, breaking things is not an option. Things are already broken, right? So just pushing forward on making it worse just to stand up some algorithm, that's not an effective approach. And frankly, this about a decade ago, that's kind of where this field was. Like, let's just shove some innovation into it and make it better. Well, we need to be a lot more deliberate, and part of that deliberation is having this kind of context. So that's one reason why it is that we talk so much about context in this course. And the other reason is this tweet from Gatekeeper Planning Professor. This person writes, the newish focus on data science, quote unquote, has trivialized the value of deep knowledge in a topic and true expertise. Now anyone who, quote, knows data can claim equal expertise to folks who have studied a topic for years. And it is a poisonous contributor to this anti-knowledge era. A poisonous contributor, really. I completely understand this sentiment. This is from an academic who has spent years honing his or her craft, learning a tremendous amount of context to the point where they feel confident that they have the ability to make a policy prescription. They have the evidence at hand to make that prescription. And this person is responding to the fact that there's a bunch of sort of newbies out there who discover an open data site, create a quick map or a quick correlation or something and just say, I've solved the problem. And I feel a couple ways about this. Number one, that shouldn't be you. I want you to have the context. I want you to be able to think through the implications of taking some interesting data and mining that data for some kind of intelligence. I want you to be able to, not just send it out into the world with the hashtag smart cities solutions. I want you to be able to empathize with the problem and be able to show that this solution is actually meaningful. The other reason so I think that's an important point. I think that's part of what Gatekeeper Planning Prof is trying to say here. But I also don't really appreciate the gatekeeping. Many of you and many students who have taken this class in the past kind of get bit by this bug. They're very, worried about, tremendous anxiety about writing a bunch of code in R, building all these modern machine learning algorithms that we're going to build. And then, what we do well in this class is teach social scientists how to use data science. And I want you to get bit by the bug. Awesome things we have seen other students, awesome things happen when that has happened to other students in the past. And so, I don't want to gatekeep this. I want you to explore your creativity with these skills that we're going to give you. At the same time, as I've now said several times, having this kind of context is really critical for what we do. And the lesson to be learned here is that ultimately, in this kind of work, context is more important than engineering chops. So your average data scientist in Silicon Valley comes with a computer science degree or an engineering background, mathematics. I think that doing data science in our world requires one to be a social scientist first. And so you'll see everything we do in this class is not motivated by the equation. If you want machine learning classes and data science classes that are motivated by cool equations, you should go over to engineering and computer science. What we do here is to motivate our questions and our problems with social science. And frankly, I found that that is a better way to get folks like you interested in the subject matter. All right, so this starts by taking a very zoomed out look at the kinds of problems we are interested in and try to understand how to convert a public policy issue into a technology use case. So a use case, I've defined it here, a specific set of circumstances that drive the development of a technology solution. The use case for an Uber app is to match a driver with a rider and get both of those individuals from point A to point B. The use case of the Zillow Zestimate is to provide an estimate of a house's value, even if that house hasn't sold in many years. I include these two use cases because we're going to be dealing with both of them this semester. But these are very simple technology goals, use cases. And the public policy sector is just not that simple. So here's an example of an anti-eviction effort that the goals of which are to provide tenants with legal protections, enact more onerous landlord regulations, strengthen code enforcement, promote affordable housing in neighborhoods of opportunity, provide better schools, provide safer streets, more intergenerational mobility, and on and on and on. This is not a technology use case. We are not going to start a startup to address such a comprehensive problem. And frankly, how comprehensive a problem this is why it's such a difficult problem to solve. But what we're going to learn to do is to try to break these out into individual components that will turn into technology use cases. And to do that, it starts off by asking, what is the policy? Policy is a set of guiding principles used to achieve a set of policy goals or outcomes. And if the data scientist does not know the policy, then it's going to be really difficult to design solutions to achieve the policy goals. And not knowing the policy is the engineering approach. It's just diving in, right? We need to step back and we need to understand the policy. Of course, what's interesting about policies is that sometimes different policies can support the same policy goals. Policies can change dramatically from administration to administration or across geographic locales. But we need to start with, what are the goals that we're trying to achieve here? And then we start asking, what are the programs in place to achieve those policy goals? And the program is the tool that's often deployed to achieve those policy goals. And this is where the operational decision-making comes into play. Understanding programs is often really difficult. It's when this is the decision-making, the 4 different decision-making approaches that I mentioned before. It's very difficult at times to figure out which one or which combination of those 4 is guiding decision-making in a given program. Another very difficult thing to understand is how effective is that program? And this is what we call program evaluation, which is very much the wheelhouse for many of my colleagues in academia who are interested in program evaluation. What is the effect of this program on these outcomes? It's quite difficult to do, and oftentimes requires a lot of econometrics or quantitative statistics, quantitative analysis. It's a different kind of public policy analytic than we will focus on here. And in fact, program evaluation is really focused on those operational decision-making questions. Should we allocate $50 million for this program? Again, we're interested in the operational decision-making. Once we have that $50 million, how do we allocate it? How do we make decisions about its allocation? So the final big question about this is, how is the program delivered? And this is where data scientists can have their greatest impact. The goal, of course, for a program, for a meaningful program, is to deliver resources when, where, and to whom they are most needed. In order to do that, we have to understand who is eligible for that program. Do participants have to actively sign up for the program, or can we target them based on certain criteria? Can we look at people who have received that program in the past, and can we learn about those experiences, and will that help us target recipients in the future? Do citizens interact with this program, like by the internet, by mail? Do they have to show up in person? And finally, I suppose the most important question is, how does data and evidence and technology help to improve a program at the margins, right? If right now the program outreach for the program happens by mail, can we create a web portal? Can we use text messaging? How can technology help? And so this idea of program delivery, sometimes called service delivery, that's the wheelhouse for data scientists working in government. And we're going to spend the most time there. But those 4 things that are really important, I just want to mention them again. Start with, what is the policy? What are the programs in place to achieve those policy goals? How effective is the program? And finally, how is the program delivered? All right. Now, resource allocation is what we do. And I'm a city planner by training, by trade. And I believe that data science is a natural extension of planning. And I don't mean planning in the context of comprehensive plan making, although data science has a role to play there too, but I mean data science in the context of more like strategic planning, and specifically around the allocation of limited resources, which is pretty much every government problem that we have to deal with. We're going to talk a lot about machine learning, which, for some of you might sound like some pie in the sky or some like crazy buzzword, but at its core, it's really about borrowing the experience of people who, from the recent past, to try to understand if that experience can generalize to people in the future. So if I can look at people who were homeless in the past and try to understand the experience that led them to the homelessness outcome, if I can learn about that experience, I can test whether that experience could generalize to people in the future. And if it does, then I can use the data to basically estimate the homelessness risk for everyone else. If I have homeless risk for everyone in Philadelphia, and I can only afford to give 1,000 new housing vouchers to those people, maybe I would find the 1,000 the top highest risk families and approach those folks by saying, I have this voucher, would you like it? And hopefully by doing that, by understanding folks with the highest risk of an outcome like that, hopefully that might prove to be an innovative way of allocating my limited resources, in this case, housing vouchers. Now, of course, it's really hard to predict things. And cities are incredibly complex systems. There's no way around that. Anyone who tells you that they can, in fact, many of the reasons that prediction fails traditionally in city planning, particularly for those of you who are second-year planners who already took the quant class, you probably built a planning like population forecast. What did you do? You took the population over the last 3 censuses, and then you just extrapolated the line outward. That was a forecast. In order to predict population, there are so many incredibly difficult, complex systems that you're predicting or that you're taking for granted when you make that prediction. There's population, there is employment and labor markets, transportation, how about a pandemic, right? Cities are incredibly complex systems. And we don't try to generate massive and very complex forecasts. What we try to do is to sort of break out a very less complex, more bounded system. And we'll build an algorithm, and then it will pay a lot of attention to how useful our algorithm will be in the context of the planning process or in the context of the decision making. This is a little difficult to understand at this stage, but you will see we're going to try to quantify a lot of the costs and benefits, despite the fact that some of these costs and benefits may be social in nature, not necessarily economic. We're going to try to understand how our algorithms perform, particularly compared to how things were done in the past. And you'll get a lot more about that. Now, if you want to know more about this kind of work that we do here, this class prepares you for the Musa practicum, which happens in the spring, where students work with actual government clients on real data science problems. I urge you to go and Google the Musa practicum, and you can see some of the very specific problems that we take on and use machine learning to solve. And I hope that by the end of this class, you will see why it is that data science is very much why it very much relates to planning. It is not anything different than planning. It's just a different and new way of thinking about planning. All right, on to the data science, on to some data stuff. If you're keeping score at home, this is the third of 4 things on this agenda. Many of the use cases we take on in this class are spatial in nature. So it's not just about resource allocation, it's about resource allocation in space. These are where questions. Where should we patrol for a crime? Where is the fire risk? There are a whole slew of questions, planning related questions that are where in nature. And those are the ones, most of what we do is going to be spatial questions. In order to do that, you have to understand some underlying dynamics about why things locate in space the way they do. Now, if you've taken a GIS class or a spatial analysis class, chances are you've seen this before, but I'm going to show it to you at a different angle. And specifically an angle related to decision-making, not surprisingly. So there are 3 spatial processes of interest that we're going to concern ourselves with. randomness, dispersion, and clustering. And I will show you examples of each of these. So there are not many phenomena of interest to us that are randomly generated in space. It's clear that developers don't build their next suburban shopping center, throw a dart at the map and be like, I'm going to build a shopping center there. It's clear that when you rented your apartment, well, many of you are obviously joining us from abroad or not in Philadelphia, but in a normal year, if you rented an apartment on campus or just off campus, you didn't randomly do that in Philadelphia. You had some decision criteria about where you wanted to rent. Well, very few things in the public policy sector are actually randomly distributed. But this is the first spatial process. Things at random in space, such as students at recess. The second one that you see less of, but is still prevalent, is things that are dispersed. And so the example in the lecture hall is the students are clearly at regular intervals from one another. That's what makes them dispersed. They are spaced out at regular intervals from one another. And why does that happen? That happens because there's some external decision maker who decided when they were designing this lecture hall that they wanted all of the students to be to have their own personal space, to social distance or what have you. There was an external reason for these decisions. The real world example, my favorite real world example of this, are fire stations. These are those from LA City, I think, LA County. And they're also regularly dispersed at regular distance from one another, or uniform distance from one another. And they do that to ensure that they all have their own fire area, there's a word for this, service area, and they're not overlapping. So in the real world, fire stations are an example of things in space that are dispersed. And again, someone has made that decision externally. Someone said, we need to have these things unto themselves so that we don't have overlapping service areas. And the last one is clustered in the lunchroom. These kids like to sit at the lunchroom at these long tables in cliques. And they are making decisions internally. The external decision maker put a long table in there, but these students are selecting into these cliques, these groups in the lunchroom. And here, the real world example, we're going to talk a lot about crime in this class. And you can see here we have clustered crime. These are clusters of burglaries in Chicago. People selecting into communities to commit these crimes. And so unlike dispersion, where you have some external decision maker who's deciding where to put the tables and why, here you were having individuals make a decision and selecting into a location. Now, with the most interesting problems, the ones that are really hard to get at, are those that have multiple scales of decision making. I'm sorry, these are all images from this book I will describe, and this one clearly needs some work. This student seems to be sitting half on the table. But this classroom here, let's imagine that the teacher decides to put these round tables in the room, spaced apart or dispersed at uniform intervals, but then the students can come in and decide which tables they want to sit at. So there is both external decision-making and internal decision-making. And we see this happening most in cities. So one example is house prices, which will be the subject of the third and fourth modules of this class and our predictive modeling competition. Here, these are home prices in Boston. You can see that they cluster across neighborhoods, and home prices are different across different neighborhoods, those outlines you see. But they also vary systematically within neighborhoods as well. Some neighborhoods are more mixed than other neighborhoods. So another example would be segregation. So the external decision-making for segregation is like institutions, banks, and the like, that make these top-down decisions that almost force people to live unto themselves. But there are likely also some self-selection. People at a certain level, certain people may prefer to live amongst people of their own race. Segregation is an example of both top-down external decision-making and bottom-up internal self-selection decision-making. And really, in order to understand house prices or segregation or many of these phenomena, the takeaway is you need to understand or think about the underlying spatial process. Sorry. And we're going to spend a lot of time thinking about these spatial processes across all the phenomena we look at. By the way, spatial process is a fancy term. It's really just the pattern. What is the spatial pattern that we're interested in? And the more you can look at any pattern of any map and try to empathize with why it is that the things are located where they are on the map, the easier it will be for you to understand the phenomena of interest. All right. I've already been talking for a while. You take a breath. Here's the syllabus. I'm going to talk about the syllabus, and then I will go through briefly the 8 modules of this course. And then I will tell you about the specific schedule and the course text, etc. Excuse me. All right. This class has both a Musa number and a city planning number. This class will meet at this time, 9 a.m. Now, for those of you who are in the Musa program, you know I have, as the director of the Musa program, I've worked really hard to make sure that all of the Musa classes, not just this one, are accessible to our friends who are joining us from abroad. And that is very much the case here. So my goal is to do the, despite this very special circumstance today, my goal is to do all of the lectures live and record them at 9 o'clock on Fridays, with the understanding that those of us, 9 o'clock Eastern time in the morning is 9 p.m. for many of you in China. And my hope is you will still be able to participate in the live lecture. The labs start at 11. Those labs are taught by Michael Fitchman and Matt Harris. I will find a way to have them introduce themselves more formally to you in a live setting next week. But they're going to run the labs. You are assigned to one of those labs. Some of you are going to ask me, can you change lab sessions? Please email the, if you want to be with your friend in a lab, or you want to, work in a group with that person, I think that's reasonable. And I don't think we have to worry about like physical chairs this year as we had in the past. I just want to make sure we have a balance. So I ask you to contact your lab instructor to ask these kind of questions. Those labs are going to be at 11 a.m. to 12:30 p.m., which is likely too late for those of you abroad. All of these things will be recorded. But our goal with all the hands involved in this class that you see there in this table, we have trying to make ourselves accessible in times that are accessible to you. So you can see those times for these office hours, Tuesdays and Wednesdays. So try to keep them in the beginning of the week. Sorry, that Tuesday 9 a.m. is an old time. I think Michael is still trying to decide on what time he wants to have his office hours. But we're going to try to come up with times, obviously in the middle of the week, because homework is due on a Friday. What else I want to say about that? You can see there in the morning or in the nighttime. My office hours are going to be Wednesday in the middle of the Eastern time day. But if you are a student who is working abroad and you would like some FaceTime with me, I'm here to make that happen. So reach out and we'll put something on the calendar. All of us have Calendly. On the Piazza site, you will see links to all of our Calendlys. And so you should use Calendly to sign up. It is the best way to do that. But my goal is overall to make sure that we are accessible to you. You are paying a lot of money for your education, for this class, and I personally believe, as someone who's not that far removed from paying for school, that you deserve FaceTime with your professors. So we are here to make that a reality for you. Course resources, I will talk about those momentarily. feel like I've talked enough about the course description, but the important takeaway is in the second paragraph there that there are 6 required projects, assignments in this course. 2 are projects; those are longer and more difficult efforts. Prerequisites for this class: either the Introduction to Vector GIS, CPLN 503, which is also taught in the fall, so first-year planners, you would have taken that last fall. The Summer GIS course that was accessible to many folks in Weitzman and beyond this summer. Thank you to Michael Fishman for leading that effort. That is a prerequisite, or really if you've had formal GIS in any other setting, an undergraduate, I think that's fine. You know, the question I always get is, do I need to have experience writing code, and particularly R code? Obviously that will be helpful, but no, I don't think it is required. You will see. One of the reasons R is powerful for many reasons, but one of the reasons it's powerful is because it is explicitly designed to be accessible to newcomers. It's a beautiful thing. And I mentioned to you that the goal of this class and the goal of everything that we do here in the Musa program is to teach data science to social scientists. And you know, I believe, and you know, I think that those who have come before you can attest to this, that if we need to teach you R from the ground up with no experience, I think we can make that happen for you. Now, I have no doubt that that's still intimidating. You know, particularly if you come here with a humanities background and you're like, I've never coded anything. I mean, I'm not going to sugarcoat it. It's going to be difficult for you. But keep in mind, this is not a coding class. We're not going to start with Hello World and learn matrix algebra and coding, things like that. I'm going to give you the code. Everything you have in this class, you have the code. Your job will be to hack it together to create something cool, something new and different. And you will see Piazza makes the ability to ask and answer code questions really easy and painless. So I ask you to bear with me. You have every right to be worried and anxious about learning coding, but we're going to get you over that, get you over the hump real fast. So you can see the grading breakdown there. Now I'm looking at it. I have to go back and make sure that that math checks out. But the projects, the bottom line is the projects are worth more than the homeworks. And your participation grade is basically half and half based on your willingness to participate in these Zoom lectures. Although, again, if you are joining us abroad and you don't feel like you can make it 9 p.m., please email me and let me know. My goal is to be as flexible as possible. But a big part of participation will come from Piazza. I will show you how you can participate in Piazza either by asking or answering questions. In the course of this class, we get hundreds of Piazza questions. And it is an awesome venue for chatting and for learning along with your peers. I have thought about how homework is due. Typically, we have homework due at the start of class, but I'm thinking about actually making homework due Friday night. And we will be in touch with you how we want you to submit your homework. So it will likely be on a Google folder. But again, trying to make this accessible for those of us joining from elsewhere. Late homework is fine, but if it's like absurdly late, you should expect to be penalized. Everything we do this year is going to be in R, which means that everything we do is going to be prepared in R Markdown, which is very easy to learn. You will see it's like beautiful for including in portfolios, which we'll talk a lot about in this class. So don't worry about that. We'll talk more about that. You are absolutely encouraged to collaborate in groups. The lab today is going to focus on GitHub and show you how to collaborate on data science projects. The only thing is that if you work in groups, like all of you together or just 2 of you, I don't really care, but everyone has to have homeworks that is uniquely yours. And the best way to do that, frankly, is around the data visualization. Data visualization is such an important part of what we do here. We'll talk a lot about using data visualization to communicate. And so the best way You can solve the problem, write most of the code, do the analysis in groups. But when it comes to your like brief write-up or memo, make that unto yourself, please. All right, and I will talk about the book in a moment. And yeah, the software for this course. You need to download R, Google download R. Make sure that you download the 64-bit version. You can download R on a PC, on Windows, on Mac, on Linux. And also download RStudio, which is the sort of front end, the interactive development environment, the IDE that we're going to use to run R. And it makes easier to, it's just added bells and whistles beyond just command line. All right, I want to go through each of the modules real quick. I'm not going to say a lot about these because you'll see a lot over the course of the semester. But the first module, which will last a couple weeks actually, is transit-oriented development. We're going to talk about the importance of indicators, why indicators often come before complex analytics. And what we'll try to do, you will do this in Philadelphia, but you will do this in another city to try to understand whether people are willing to pay more for housing in areas that are accessible to transit. Module 2, we will look at an urban growth area in Lancaster, Pennsylvania, and we will come up with a method for figuring out strategically in which town in the county we should expand the urban growth boundary. These first two modules are really about descriptive data science. It's a lot about indicators, and it's a lot about learning how to do data wrangling and geoprocessing in R. And that includes wrangling census data. So these are really some core R skills for wrangling spatial and aspatial data in R. And in Module 3, we get into, I think, really the meat of the semester, beginning with it's one module, but it's 2 chapters in the book on geospatial machine learning, looking at home prices. We're gonna, the book chapters deal with Boston. This year, we're gonna be building predictive models of home prices in Miami, which I think is a really interesting city to be doing this in now, given climate change. And I will tell you all about the predictive modeling competition. I'm hoping they're not going to, in the past, we have done a predictive modeling competition with cash prizes, because I find that the best way to incentivize people's work is to pay them for good work. So I will give you some home prices, and I will also give you some addresses that I will withhold the actual price. You will try to build a model that learns the price for those I've given you, and you will predict on those that I've withheld. Everyone will do this in teams, and the team that has, I think the top 2 teams that have the lowest amount of errors, that is, that predict the best, they will win prizes. And also the team that uses data visualization to submit the best visual submission, they will also win a prize. And this is where we'll really start getting into a lot of the machine learning work. Obviously, it's not just this module, but really this module 4, which is about really understanding the spatial process in home prices using these 3 spatial processes that we touched on already. This will also last a few weeks. And then that will move us into predictive policing, which is something that it's been important to my work for some time. I think that with the events of this past summer, namely George Floyd protests, this has really come back into the mainstream. So folks have had a problem with predictive policing as an algorithm that government should be building for many years now. And we're gonna learn how to build these models. We're gonna learn why they're so problematic from a social science point of view. And we're gonna start opening up the black box of our models to understand how fair they are. And specifically how fair they are as a decision-making tool, which is why we'd be building a predictive policing algorithm. It's about where do we allocate police patrols. So we'll do this in Chicago. And I think it's one of the chapters that tends to bring up the most amount of discussion in the throughout of the entire semester. And then we'll move from geospatial predictive modeling to individual modeling of individuals, which is obviously really important in government that has programs and resource allocation not in places but to households, to families, etc. So we'll talk in this chapter a lot about decision making in the context of cost and benefit. These kind of algorithms are, if you are interested in working in the private sector, get good at these kind of algorithms where you can attribute cost and benefit to them. These are the algorithms that tend to run the world now in marketing, in finance, and insurance. And in my opinion, those use cases and those domains are boring. Those cost benefits deal only with profit and revenue. Cost benefit in our world is so much more nuanced with this idea of social costs. You're going to see a lot more about that. We will continue in the algorithmic fairness vein, looking more at criminal justice, focused on individual predictions for these individual level models. And we'll talk about algorithmic fairness. How well does a model work for different individuals across races? This is also something very much in the popular sphere right now. And again, we're not going to focus on engineering solutions. Obviously, we're writing code, building analytics, but we will see, and we will seek this very much in a social science discussion around discrimination and around fairness. And the last module will be around space-time forecasting using rideshare data from Chicago. And this is an example of rideshare trips in a subset of Chicago for every hour a day for 7 days a week. So those are the 8 modules. And everything will focus on this book. This is the latest draft of the cover that I have for this book. The book is technically due September 30th. It's been, I think, several years in creation, but it's now all in one place. They are going to print it in print, as you see here, but it'll also be printed in, it'll also be available for free on the web at this link here. This will be posted on Piazza by the time you are all seeing this presentation. But let me see. Here's the book when you go to the site. Right now it's behind a password because it's not open yet. Probably in early October. Hopefully it'll be done enough that I can open it up to the world. But there is a password. It is Ken's_book. You'll see it on Piazza. It is not just one insanely long website. If you hit the letter S for now, you can toggle the table of contents. This book is very much like a construction site. So even over the next few weeks, I'll be making changes. And as you read it, I hope you will point out to me typos, things that are confusing. This book, for the last couple years, pieces of this have been used in this class and have relied on your colleagues in the past to help me make it better. So this first chapter is the introduction. I ask that you read this for next week. There is the other 8 chapters that you can see here. All of the text is there, all of the data visualizations are there, but most importantly, all of the code is there. And the idea is you could actually read these chapters unto themselves, or if you want to, you can copy the code and paste it into R. So this is the text, and I'm excited to have it mostly together for this year, hopefully every other year, teaching this class in the future. But again, you can go to Piazza and you can check out the link for this. And here is the calendar. You can look at this on the syllabus, which you can also access on Piazza. I just want to mention that the first assignment isn't due until effectively the end of the month. I feel like there's going to be a lot of, everyone's going to need some time to get used to the quote unquote new normal. And so I wanted to give you all time to really to spend time on this first assignment. And you will see that there are really 2 book chapters that I would like you to, 3 book chapters if you include the introduction, that I would like to read leading up to this assignment date. So Why Start with Indicators is the book chapter that's specifically on the TOD assignment, but this chapter 2, urban growth area expansion, will also play a role with respect to geoprocessing. Another thing notable about the schedule is October 9th. We will not have class that day, but we're going to have a one semester, probably the most important Musa event that we do every year or every semester, called the Musa Masterclass. And it's going to focus on network analysis in R with Professor Kyle Walker, who has authored a number of really important R spatial packages. This package is taps into the Mapbox API. If you don't know the company Mapbox, Google them. They are going to sponsor this event. The masterclass is actually, it's not just for us, it is attended by folks all over the world. So Kyle will put together a tutorial just for this masterclass, and he will guide us on this tutorial, and then he'll turn it over to everyone working across the world to replicate what he's taught us on a different data set. And we'll all come together and post the results on social media. It tends to be a really wonderful community building endeavor, not only for our students, but also for others who join us from across the world. You can see the home price midterm project. The competition is due in the middle of October. And then towards the end, we start moving towards this final project. And I want to mention our other guest speaker is Dennis Colhane, who is a colleague of mine, who is not only is he a world expert on the subject of homelessness. He was on 60 Minutes actually in December talking about homelessness, but he's also very much one of the foremost experts on governance, what we talked about at the very beginning in New York City, and specifically governance with very private data that governments collect about education records, about health records, etc. That's going to be a really great talk. And you'll see, we'll move towards, after that, we'll have another lecture that Matt will give us about creating a portfolio. Thanksgiving, there's no class, and then when we come back, we'll have final project presentations. So I'm going to talk a lot more about this as the course comes on. I'm sure you'll have a lot more questions about that. Finally, Piazza. I'm not going to I guess I can. The Piazza page right now is blank. I haven't, I won't probably add your emails until, or maybe I'll have Michael add your emails late next week. If you haven't used Piazza before, it's a really wonderful resource, particularly for us that can have a lot of coding questions. You will see this resources tab is really important, where you can access assignments. But this Q&A place is where you're going to go the most. So there will be a folder for every homework. I still have to customize these. And you click on a new post, you ask a question. Now what's great about these questions is that they can be voted up and down. Now while normally I don't think you should pay much attention to imaginary internet points, in this case, remember it does go to your participation grade. So if you care about a grade, you should participate in Piazza. But this might sound a little corny, but I really do think that Piazza facilitates a really nice community feel to the class, which is something increasingly I feel like we're going to miss this semester. So I urge you to post questions and answers on Piazza. You can also post interesting things that you find related to the kinds of work that we're going to do here. These algorithms are very much in the news cycle today. So in the past, I know we've had some really interesting conversations about some of these subjects in Piazza. All right. I have talked for a long time, and I don't think I can talk much longer. Now, normally at this stage, there'd be a lot more conversation, and it's exciting that I have a new child. This fall is going to be crazy between that new child and homeschooling a second grader. But I'm here to answer your questions. I will be, let's assume that this baby came, like it's coming right now, and that's why I'm not here. Today is Friday. I will probably be back in front of my email on Sunday. So there's a lab after this. You can ask the lab instructors questions. I want to make sure we don't get our wires crossed. So I think it's useful to post those questions on Piazza or to email me them. Piazza is the best place so that everyone can benefit from your question. I want to reiterate the fact that this class is very much a combination of context and code. If you are worried about the code, don't be. We will make it work for you. You just have to be willing to put in the time to learn something challenging. It's not going to be easy. It will be challenging. And the most important thing, the most important key to success in this class is curiosity. It's not wanting to learn code per se, but it's wanting to solve a problem, wanting to get to the core of some of the public policy questions or modules that I pointed out in my presentation. So I want you to please be curious, all right? That's going to be the best determinant of how successful you are in this class. And yeah, we will meet tomorrow. I'm sorry, tomorrow. We will meet next Friday, and we will jump into some code, talking about transit-oriented development. And I think that's all I got. So I'm sorry I can't be with you all today. I look forward to chatting with you all as the semester plays out. And have a great day.